Alright, now we're going to go through the tedious process of hand finding an approximation for the function for the x-intercepts, or an x-intercept of the function x to the fourth plus x plus 2. Okay, so approximately find an x-intercept. By the way, that's equivalent to finding solutions to the equation x to the fourth plus x plus 2 equals 0. So finding an x-intercept of this function is equivalent to finding solutions or roots to this equation. So you could be asked to find roots of an equation, and you would want to think of it in terms of a function. So the first thing we want to do is we want to start with a guess. And that's what this process is. Guess x equals blank might be an approximate x-intercept. So that's a difficult thing to do in some cases. So let's go over to Microsoft Excel. And here I've got some x values from -50 to 50, and I've got the y values for this function, and I'd like for y to be 0. So we can see that close to 0 I have the smallest y values. So what I'll do is now I will change maybe -50 to 50 to -5 to 5. So let's say -5, -4. Let's just repeat that. And now we can see we still have big values at -5 and 5, but you know, -1 and 0 seem to give us y values pretty close to 0. Maybe let's start with x equals 0 to be our first approximation in our Newton's method. So we're going to guess x equals 0, and what we just did in Microsoft Excel can also be done on lots of calculators using a table function. So you might want to learn how to use your table function if you have a scientific calculator or something. So guess x equals 0, and the first thing we need to do is we need to find the tangent line at x equals 0. Okay? In order to get the tangent line, I need the slope of the tangent line, which requires me to know the derivative of this function. So let's come back up here and say that f prime of x is 4x cubed plus 1. And we'll use that every time we want to calculate a slope. So we can say that m is the slope of the tangent line. So it's f prime of, and we're at 0, so f prime of 0. If I plug 0 into this, I get 4 times 0 cubed plus 1, which is 1. So there's our slope. Then we need a point on this line. Well, we know x is 0, and we know the tangent line shares a point with this function, right? The whole idea is the tangent line at the point where x is 0. So y would be 0 to the fourth plus 0 plus 2, which is 2. So the tangent line equation, using point slope form, would be y minus this y coordinate 2 equals the slope of 1 times the quantity x minus this x coordinate of 0. Okay, so that is the linear approximation, or the tangent line. So when we find this tangent line, that's simply a linear approximation of the function, and that is at x equals 0. But now what we need to do is we need to find the x-intercept of this linear approximation, or of this tangent line. X-intercepts of lines are easy. In general, to get an x-intercept, you plug in 0 for y. So if we do that and solve for x, and I'm going to write this out in an unusual way just to develop a pattern. We have 0 minus 2, so I'm going to divide that by 1. So -2 divided by 1, and then I'll add 0 to get x by itself. So that's how you would solve this equation for x, and that would be the x-intercept, which of course is -2. Okay, step 2. We would guess. This is our new guess for the x-intercept of the function, right? So our goal is to keep finding the x-intercepts of the tangent lines and use those to be our guess for the x-intercept of the original function. So guess x equals -2. And then we repeat. We look for the tangent line so we can get the x-intercept of it. And remember that the slope is given by 4x cubed plus 1. So we know that m equals f prime of negative 2, which is 4 times negative 2 cubed plus 1, which is negative 31. The equation then, we need a point now. Well, the point on the line is where x is negative 2. And we plug that into the original function, which was x to the 4th plus x plus 2. And in that case, you get 16. So you can plug that into the original function. And so now we have the equation of the tangent line, y minus 16 equals negative 31 times x plus 2. The x-intercept of the tangent line, or the linear approximation, is what you get when you plug in 0 for y and solve for x. So x will be negative 16 divided by negative 31, right? Divide negative 16 by negative 31 and then subtract 2 to get x by itself. And that ends up being negative 46 over 31. Now that's our third iteration now of Newton's method to guess or approximate the x-intercept. So we'll guess that the x-intercept is negative 46 over 31. We will calculate its tangent line the same way we've done every other time. And if you do that, you'll get an equation that's approximately y minus 5.36, and you can carry more decimals in your calculations here. I'll put dot 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 because you've already found the slope and things. Y minus 5.36 equals the slope, which if you calculate, you get negative 12.07 approximately, times x plus 46 over 31. The x-intercept, if you plug in 0 for y, you get x equals negative 5.36 divided by negative 12.07. Subtract negative 46, or subtract 46 over 31, and you get negative 1.04. Sorry, negative 1.04. And you can do this as many times as you want. In fact, you might want to check if you do it one more time. So our fourth iteration, our guess would be, our approximation for the x-intercept would be negative 1.04. If you do all the same things, then your fifth iteration would result in, well, this would result in an x-intercept of your tangent line of negative 0.431 approximately. And so we might say, okay, we're going to guess that x equals negative 0.431 as our x-intercept. And if you plug that into the function, you might get something close to 0 to illustrate that this is close to the x-intercept. And this process could continue as long as you want to do it.